Welcome to the Sustainability Podcast's newest series, America's Path to Net Zero. This series is dedicated to the investment made by the U.S. in the pursuit of a net zero emissions and a greener tomorrow. In the next 4 episodes, I will be covering emerging industries, established technologies, future policies, and the impact of the Inflation Reduction Act. The featured guests include ARC's finest analyst and the founder of the American Energy Society. I hope this series leaves you with a better understanding of the Inflation Reduction Act, emerging decarbonization technologies, and your role in the energy transition. Good morning, Rick. How are you doing today?
I'm doing great, Gavin. How are you today?
Doing pretty well. This is the second installment of the America's investment in net zero, in our path to net zero. This is a series I'm building focused around the Inflation Reduction Act and how close the Inflation Reduction Act will get us to our net zero and decarbonization goals. Yesterday, I spoke with Eric Vettel from the American Energy Society, and today I'm speaking with Rick Rys, my colleague at ARC. Rick, would you like to provide a nice background of yourself and how you found yourself working with ARC?
Yeah, so I am a market analyst at ARC for the past 6 years. I have quite a good background in chemical oil and gas industry. With regards to today's topic of hydrogen, I have actually worked in a chlor-alkali plant that is one of the significant producers of hydrogen. And I've also worked in many refineries and worked on the control systems for the whole hydrogen production and distribution process within those refineries. So I have a background in control system engineering, but I also follow the whole energy transition and have covered market studies for ARC about grid automation, microgrids, substation automation, grid scale batteries, and more recently produced market studies on hydrogen electrolyzers.
That's an extensive background that you have there. As you know, the Inflation Reduction Act covers economics, policy, and technology. Yesterday, I spoke with Eric about the more of the technological and policy side, and today I wanted to speak with you about hydrogen and the technological side as well. Can you give us maybe a background or a baseline of what the hydrogen market looks like today in the US and where you think it could go?
We have a hydrogen market today, but the production of hydrogen makes a lot of CO2, and this is a problem that needs to be fixed. Today, 95% of hydrogen produced in the world is black, brown, or gray hydrogen. That means it's sourced from coal, oil, or natural gas. Hydrogen production obviously is a big contributor to global warming. In fact, it's at 2.2% of the total worldwide greenhouse gas emissions. About 2% of hydrogen is actually produced by a byproduct chlorine caustic soda production, 1% by blue hydrogen, and 0.4% from green hydrogen. But green hydrogen, even though it's very small today, is growing very fast. About 55% of the hydrogen made around the world goes to ammonia production, 25% used in oil refining for desulfurization and hydrocracking and other reactors, and about 10% is used to produce methanol. The last 10% actually is distributed over many other specialized uses like generator coolants, rocket fuel, bottle gases, and many other niche uses of hydrogen. So, Gavin, I wanted to share about the thought process of how people might think about hydrogen. So I want to give us a little bit of a story about how my own thoughts about hydrogen evolved. And they'll come in 3 different versions, 3 different thought processes. My very first impression of hydrogen is, wow, it's a clean, energy-dense fuel. We know it can work to power the same types of machines that fossil fuels power today. That would include engines, gas turbines, fuel cells to make electric power, boilers to make steam, or devices to heat buildings. Additionally, low-carbon hydrogen could displace all the gray hydrogen we use today, and major reductions of greenhouse gas emissions would result. But also hydrogen demand will grow with steel, cement, and transportation. What's not to like about hydrogen? So that was my first impression. But, as an engineer, the second impression came pretty quickly. And that was basically, oh yeah, hydrogen is only an energy carrier. So it needs to be made without greenhouse gas emissions. And it's expensive to make hydrogen for the amount of electricity that's needed to use electrolysis. Most of the hydrogen we make today is produced from steam methane reforming or gasification, but our hydrogen options for reducing greenhouse gas emissions include so-called blue hydrogen, which is steam methane reforming with carbon capture and storage, and or green hydrogen, which is made from electrolysis of water, but it must use clean, carbon-free power. Both of these options have challenges with cost and complexity. And in fact, on further thought, we don't really have any hydrogen distribution system. And it's hard to transport hydrogen due to the exceptionally low density and special safety and handling needs. It needs its own pipelines. It's not particularly useful to transport by truck. And even if we had a distribution system, we don't have all the final end-use devices. So we don't have all of the new engines, fuel cells, boilers, and industrial process changes to switch to hydrogen. And these would be expensive to make the transition. So it would be no small task for refineries or ammonia plants, the main consumers of hydrogen today, to switch to blue or green hydrogen. So my second impression was, yikes, the challenges look daunting to transition to a hydrogen economy. So then comes my third impression, all right? Why are all of these companies building out parts of the hydrogen economy for a low carbon hydrogen market that does not exist today yet? As we look at the electrolyzer market and the amount of hydrogen products going into service today, it is astronomically growing. The oil industry is promoting blue hydrogen, and dozens of demonstration projects have been built. And there are many government grants, tax breaks, and even ammonia or steel mills building demonstration plants. But actually, most of the industry is sitting on the sidelines as the green hydrogen economy is not quite in place yet. So is all this hype and news reporting of new hydrogen projects justified, or just a short-term fad until the grants stop? The driving force for moving to hydrogen is obviously the urgent need to stop the greenhouse gas emissions, and we pretty much lost hope of the 1.5 degrees centigrade global warming target by 2100, and even 2 degrees is slipping away. And the International Energy Agency reports that hydrogen produced from fossil fuels is making 830 million tons of CO2 per year, which, as mentioned, is about 2.2% of the total global greenhouse gas emissions. Methane is also a target, and about 9% of the natural gas that gets to a steam methane reformer is lost in the production process. So this is one of the penalties that blue hydrogen will have, and one of the criticisms that it's been levied at it recently. And methane is 85 times more potent as a greenhouse gas. So this transition to green hydrogen, or at least low carbon hydrogen, will be driven by government policy and regulations using incentives and more penalizing or directly regulating these emissions. To meet our climate goals of net zero by 2050, a hydrogen economy is essential. You can't avoid it. And companies are observing that government policy has been shifting fast to create a low carbon hydrogen market. They will continue with more expansive policies. There is considerable uncertainty about how this plays out in different regional locations and all the timing of how it will play out. So in short, low carbon hydrogen is coming. It's inevitable, but there's a challenge to understand how it will unfold.
Wow, Rick, that was great. Thank you so much. With the passing of the Inflation Reduction Act this past August, was there any specific points of investment within green hydrogen or blue hydrogen under the Inflation Reduction Act? And how will green hydrogen unfold in the future?
The United States is actually playing catch up with Europe and Asia in the green hydrogen market. And we have suddenly seen quite a large amount of impact as a result of the Inflation Recovery Act of 2022. This includes a 10-year tax credit of $3 per kilogram of hydrogen, and it also gives tax credits on the electric power used to make green hydrogen. So this is a big incentive. So this is kind of the carrot approach. The oil industry has also built several blue hydrogen demonstration projects, and so far they have outpaced green hydrogen. But green hydrogen is catching up quickly. And there's a competition to see which technology will ultimately prevail. The potential is to grow green hydrogen from the tiny industry it is today to become the primary way the world makes hydrogen. India has great ambitions to use solar power to make green hydrogen for their large ammonia industry. New refineries have added green hydrogen units, but most of the industry is still sitting on the sidelines waiting to see how the transition will impact their profitability and competitiveness. Government policy and regulations have focused on incentivizing the production, distribution, and end use. We see a lot of projects in play today. But in order for the transition for clean hydrogen to make a difference on the 2.2% of global greenhouse gas emissions, it will take both government regulations and incentives. A key to this is the abundant, low-cost, carbon-free electric power. And that will take some time. The electric grid still has a certain amount of carbon content in all the electricity that's produced. That is changing fast, though. The electric utility industry is moving very quickly to get clean power on the grid and the overall strategy to electrify everything, including hydrogen. So there are many new companies that are establishing a foothold in the hydrogen revolution. And there are also many competing technologies for making hydrogen without greenhouse gas emissions. Green hydrogen is competing with blue hydrogen today, but it will also need to compete with turquoise and pink hydrogen. Turquoise hydrogen uses pyrolysis to convert methane to hydrogen and a solid carbon black. It has no CO2 emissions and a much lower cost of energy. It may emerge as a competitor to green hydrogen. Because it's basically easier to remove hydrogen from a carbon than it is to remove hydrogen from oxygen. Pink hydrogen is also another competitor that may be down the road. This is basically using low-cost nuclear power to make low-carbon. This is basically using low-carbon electric power to make hydrogen. And a lot of the new small modular reactors that are under development are looking to couple the SOEC, or solid oxide electrolysis cell technology, with their electrolyzers, where they can recover some thermal heat and also electrical heat and make hydrogen more efficiently than just simple green hydrogen.
Wow, Rick, thank you so much for that information. Do you want to give an opportunity to give a nice summarization of what was said? And do you have any personal opinions on the Inflation Reduction Act and its investments in hydrogen? Do you think it's enough? How much farther do we have to go? I would like to hear your thoughts on that.
In summary, the hydrogen transition is happening very fast. There's tons of stuff happening. It's more than just hype. And there are great opportunities for developing new business models and for establishing yourself as a supplier or service supplier. And the timing and technology will be a question about who will win and maybe who will fail. The Inflation Recovery Act is obviously a great start. It is an incentive-based program, kind of encouraging reducing the cost of making green hydrogen. However, additional regulations will eventually be required worldwide, and it would need to be kind of consistent between all of the global entities, US, Europe, China, to basically discourage the release of greenhouse gas emissions. And a combination of it could be done with with either incentives or regulations, and perhaps some combination of the two will ultimately prevail. And some combination of the two is ultimately required in order to really meet our greenhouse gas goals.
Awesome. Well, thank you so much, Rick. Would you like to share your email so anybody can follow up with you and maybe to speak about the hydrogen electrolyzer study that you just completed?
Yes, you can find me at arcweb.com. My name is Rick Rys, R-Y-S. My email is rrys@arcweb.com. And if you search around the ARC website, you will find a new hydrogen electrolyzer market report and some blog reports and a lot of other writings that are related to hydrogen.